Howdy again, it's Mr. Pete, and this is part 2 of my little build on this drill press vise. Remember, this was designed to be made in a high school by shop students, although it's a little bit difficult. This is part 2. I hope you have watched part 1, because in part 1 I laid out and drilled and reamed all these alignment holes in these 3 pieces, so I will continue with the build. I'm afraid this is going to be a long video compared to the first one. I didn't quite get them cut in half. So today we'll dig right in by talking a little bit about the holes and the accuracy, and then we're going to get into the screw and the assembly and many other operations that are extremely useful even if you do not make this particular vise or this particular item. Just general shop principles and operations that can be used in your everyday shop life. And I hope you enjoy the video, and I hope you love working in your shop. It's so much better than TV or any other diversions that you might have in life. So if you don't have any of this equipment or tools, start accumulating it now, especially if you're young. If you can't afford it, a little bit at a time. All right, let's get going here. There's an awful lot of hand fitting that you have to do. For instance, this reamer that I use is possibly worn just a little bit, so the holes were just a little bit undersized when I tried to insert the guide rods that I had made some time ago. And this is 1/2 inch material, faced on both ends to a length of, and you can make them any length you want, but these are 5 inches. If you want to make the vise bigger, make it bigger. And if you want to use different size rods depending on your material, that's fine too. But the point being here that I did polish these up good, because remember, cold rolled, cold drawn stock is not always perfectly accurate. So let's get those started. And what I did, because they didn't go in initially, also notice that I got them marked here for assembly purposes. Well, I got them marked all right, and I just put them together backwards. How about that? Okay, that was a waste of time. Now you can see that they are marked. Now what I did here, and sometimes I just hold them together with short pieces that I made, and I did run another reamer through here because I know this one's perfectly sharp and on size, 1/2 inch. Even at that, it's a little bit tight getting it started, so put a tap wrench on there. Anyway, it will go, I guarantee that. Well, I got hundreds of reamers, some oversized, some undersized, some worn, some power reamers, and some hand reamers, but you can see how freely that moves and how freely this rod moves. But let me take just a moment to explain something about reamers if you didn't know this. Remember, never run them backwards when you're withdrawing them. That dulls them. But a hand reamer has a taper on the end. It's going to vary with the diameter, but perhaps a 1/2 inch of taper. So it's undersized right here to help you get it started. You won't find that true so much on chucking reamers, power reamers. However, they have a chamfer on the end to help you get them started. So it's very helpful to have both, or oversized reamers or adjustable reamers. All right, enough on that. And as you can see, the guide bars move freely. Polish them if needed. And do the jaws slide? Yeah. Does the middle one slide? Yeah, but remember, I may have to ream that oversized so I have a little bit of play in the movable jaw. I talked about that before, but that will be a little bit in the future here. So I'm very satisfied. If it doesn't slide, I got to tell you, you got to start over. That's why what I have shown you in video part 1 is so important for the alignment of the holes. Okay, let's talk about the screw now. That's the thing that I'm going to make next. Of course, you could start with a big piece of hex stock, turn it down on the lathe and thread it by the single point method or with a die or whatever method you want. But just think of trying to do that in a beginning class at high school. So what I normally did there was to give them threaded rod. So here's a piece of 1/2" 13 rod, and you know what I did? I don't like the plating, the looks of the plating, so I put it in citric acid, and thank you to the man that sent me some citric acid overnight, and that took the plating off. Maybe you like the plating, but I do not particularly like it. And what I'm using here for a nut, and you don't have to have a nut. You know, you can just run the handle right through the threaded rod. I do not like that looks. This could be round stock, but I'm starting with what we call coupler nuts. Here's a big old coupler nut. You can get these in the hardware store. It'll be available right near where you get the threaded rod. And again, I took the plating off of it. So what I'm going to do here is, oh, I can't find things here, and it's right in front of me. Wait till you get old. Well, it was on the floor where I sprayed it with oil. No wonder I couldn't find it. And that was 7 minutes ago, and I forgot already. So you can see here that that fits on nicely, and I'm going to cut this roughly in half, or whatever length you like it. It'll be faced, it'll be drilled, and it could be Loctited on there. I don't know if it's necessary, but to start with, and boy, that's a nice fit. Let's talk about the end here that has to go into the movable jaw, and there's 2 ways of doing that. So let's take a look at how I did this, and this is a dog point screw, or set screw rather, and you can see there's a groove in there. I'll talk about other ways of doing that. Notice there's a little slop there. You really need that. You don't want too tight of a fit. But the dog point, and this is a dog point set screw. You'll have to make your own. This is much larger. I'm just using it as a teaching aid. So let's take this out and talk about 2 different methods here. See, to me this is ugly with the plating, and then we lost about half the plating on this threaded rod. So anyway, on the end here, I'll talk about the groove in a few minutes here. Notice that I faced the end of the screw perfectly flat, because the idea here is that it has to push against the movable jaw. So on the original here, I took an end mill. You're not going to be able to tell that, but I took an end mill and I flattened the bottom of this hole so that the flat end will push. Now the alternate way of doing that, and I'm going to do that on today's project, is that's just been drilled, so the shape of the bottom of the hole is 59 degrees or 118 included angle, the same as any drill bit. So what I'm going to do on the end of this, after I turn it to diameter, is put an angle on the end that is the same as the angle in the blind hole. Is that clear as mud to you? And I will start here by taking it over under the lathe, and I'm going to turn it down to 3/8. How far back? Doesn't matter. It's about 5/8, I believe. I'll tell you in a minute. So let's turn the end of this down and then put that little taper on there, and I'll try to rush through that for you. I have set the compound for 59 degrees to turn the angle. I've got a tool in there, and let me reposition the camera. No big deal. Have you got your safety glasses on? Okay, there it is. Now that the end is tapered, I'm going to turn it down to 3/8 diameter, and I'll make it 1/2 inch long is what I'm going to do, and it'll be just fine. And always test it out before you take the work out, and it fits just perfectly. Little bit of a play in there. We don't want it too tight, and you'll struggle with it later on. Alright, do you fully understand the 2 methods here? The flat end and the tapered end, which is exactly the taper of the drill. All right, that aside, it fits up nicely into the movable jaw. I probably could have made the step a little bit longer, but you can see that the thread does not interfere with the hole. Now I already took the liberty of transferring that hole and the center of it up to the top, and I have center punched it, and of course that's where this set screw is going to be installed. And I did put it a little bit off center, and you might see why later. Maybe it doesn't make any sense right now, but whatever that is, you can put it in the center. I didn't. Let me put it that way. All right, and the next thing I need to do then is to drill and tap this hole. Now that little dog point that I made is going to be 1/4 Let me find that and show it to you. Well, I got all kinds of set screws, so I'm taking a 1/4 socket head set screw, and I put it in the Atlas lathe and turned it down. And yes, it is hard, but it turns all right. So that's about what it looks like. And the diameter there, well, I better mic it. I forgot, because I made this 2 weeks ago. Well, it's 176. Don't ask me where I came up with that dimension. You can change that a little bit if you want to. And the length is about 100 thousandths. So that's all there is to it if you want to use this method. I might have already said it, but I'm not going to show that operation. You know, this was a cup point set screw. That's why you see that little dimple there, but it doesn't hurt a darn thing, does it? Okay, this is an old Palmgren vise, and I took liberties with their design, but you can see the taper on the end of the screw, and they made that step plenty long, didn't they? And that, of course, is held in by a dog point screw. Let me show you some other methods. I know I waste a lot of time with alternate methods, but you know, I'm no genius, so I'm copying this. On the hundreds of Peterson product vices in 2 sizes that we made in the high school shop over the years, this is how we did it. I'm not saying that's any better. Actually, it's kind of tricky because you need this pocket milled in there, or a counter bore. But can you see that there is a retaining ring in there? So that's the method we used. And of course the ring is just, and the set screw is just, the purpose is so that you can back the jaw out. So it doesn't have to be very strong. And this little 7/16 snap ring is probably kind of weak. Am I confusing you? But here's another method that somebody used, and I've never seen it done before, but it's some kind of retaining bracket, almost like a little horseshoe that goes on there, but then you got 2 other holes to drill and tap, so that's not particularly easy, but it appears to be extremely strong and useful. Those aren't the good words, but you get the point, or do you? For best results, use a Starrett center punch and a copper hammer. Now I'm going to drill 13/64 and tap it 1/4 right on through, and then I'll have to deburr that. And I'm not going to show you that because it's such routine work that has been shown, and you understand, don't you? So 1/4 hole. Deburr it. You know, I don't usually show my mistakes because I don't make any. But I'm going to show you this. I wish I would have located the hole a little bit farther outboard here where you see the pointer, at least a 1/16 of an inch, because I ran into a problem here. And here it is. I made a big deal about the angle here and all of that. But take a look what happened here, or is happening. So when I insert the screw in there, I am, you can see the taper. So in effect we've got this going. So the location of that little slot is going to be thrown way off. So what I'm going to do here is backtrack. I'm going to go to plan A and flatten the end just like this. I will have to lengthen this a little bit, and I am going to flatten the bottom of the hole. I'll do that on the milling machine with a 1/2 inch end mill, and I'm going to, or a 3/8 end mill rather, and I'm going to do that off camera, and I'll be back to you in a minute, hopefully with the corrections, and I still haven't tapped that hole. Boy, I hate to do rework like that, and I'm ashamed of myself, but from now on I'm going to show my mistakes. I know some of the other creators do as well. But I flattened the bottom of the hole, I made it a little deeper, and boy, don't go all the way through, or you got to start from scratch. I lengthened the step, and now it fits in there quite nicely. I'm still not ready to put the slot in, so the next thing I'm going to do is tap 1/4-20. I've been talking about that for 15 minutes, but here's a little secret. It took me 50 years to figure it out. When you tap something like this material is kind of hard. You know, it's cold drawn, cold rolled, so you don't need a thread that long. So it's a 13/64 hole right there, drilled all the way through, and a 1/4 inch clearance drilled, oh, I don't know, 1/8 inch deep. So there's less to tap, less chance of breaking a tap, especially in a school. You got to think about things like that. So I'll use a taper tap, off camera of course, and then finish with a plug tap, because as you can see, the taper tap is going to hit the bottom before all of the tapered teeth have had a chance to cut. Also, that stepped hole there allows you to tap straighter, right? It kind of gets you started straight. And always use some tapping fluid. Okay, that's much better. You can see that it's tapped. Now, one thing I didn't say earlier, I think I did mention, make sure to remove all the burrs, but take your countersink and countersink every last hole a little bit like that, on both sides, and it helps a lot, even this one, just a little bit to get the burrs off. Alright, this piece is about done. Now we got to get back to putting the groove in the end of the screw. Hope I didn't make that screw too short and have to start all over. Okay, I need to locate the slot. And how are you going to do that? You're going to measure. There's a lot of ways of doing it, but I'm going to take a 13/64 transfer punch, put it in like that. Make sure that the screw is pushed all the way into the jaw when you do that. I know my hand's in the way, and give it a good whack. And can you see it? So that will be the center of the slot. And how wide should the slot be? Again, I think I mentioned that before, but wider than this, so that's really 3/16, isn't it? And how deep? Well, you know, on one of the commercial ones, they really went deep, didn't they? But I'm going to make it about a 1/4 inch diameter. That's not how deep, but I guess that's a 1/16 inch deep. That can vary. Alright, the work is in the 3-jaw chuck, and I've got a cutoff tool, parting tool there. And can you see that the center of the parting tool right now is lining up with the center of that center punch mark that I made with the transfer punch? So I'm going to go into the depth that I described a few minutes ago, and then I'll widen that a little bit, equal amount on each side of the center, because the cutoff tool is only 3/32 of an inch wide. Now I'm not going to be able to show much of that, so I'll be back in a minute. I won't show you measuring that, but it is 1/4 inch in diameter into the slot. And now I'm going to back the tool out and move the carriage. And I've got a carriage stop set. I'm going to move it 12 thousandths on this side, cut it, and then 12 thousandths on the other side, and then make darn sure that that little dog point screw fits, and then the slot is done finally. Alright, the slot is done, and as you can see, the little set screw point fits in there nicely, just with a little wiggle. You gotta have some wiggle room. And I like to test fit before I take it out of a machine. So let me snug this up. Remember, you don't tighten this, you just Bring it down close, and you can see that the jaw will not come out, but yet a little bit of play there. I love it. Okay, this is a little bit of a sidelight, if the video isn't long enough already. It helps so much if you have some of this information committed to memory. Now, I know we got wall charts and we got the little charts here, but you know, you should know that 1/8 of an inch is 0.125. You should know that the tap drill size for 1/4 20 is 13/64, etc., etc. Now, when I worked at Osborne Engineering when I was 22 years old, I worked out in the shop with a young guy, and he wasn't the smartest, but he wasn't bad, but he absolutely worshipped his brother, who was an engineer in the engineering department, because his brother knew every one of these by heart. Now, you don't really need to do that to know all of them, but it's nice to know some of them. Enough with that little rant. Okay, I've got a pretty good fit here, as you can see. Whoops, that jaw's moving. So the next thing I'm going to do, and you know what, I wish I would have made the screw just a little bit longer, because I'd like to have, this is way too long, of course, and I would like to have a hex about like that. Now that's not quite going to fit. That one would fit. Of course, I can cut the guide rods off a little bit too. In other words, foreshorten the project. That's probably what I'll do. So I'm going to cut off a piece of this now, 1/2 Go ahead and put that on, and then I need to drill that hole. While you were at the refrigerator, I did a couple things here. I shortened the rods by about 5/16, so I didn't have to make a new screw. Doesn't matter at all. I cut this nut off, and it still will be trimmed, but I got it just about where I want it right there. So the next thing I will do is to face off the end here. There's a little bit sticking out. And maybe even before I do that, I'll go ahead and drill the hole for the handle. And since this will be 1/4 inch, the hole will be one size over 1/4 inch. Never drill it the same size or it won't slide, it'll bind, it'll be a mini nightmare for you. And speaking of nightmares, let me back up to teaching, you know, years and years ago. At the end, this was a difficult project. At the end of the year, you would find things such as all kinds of miscut or damaged pieces in lockers, unfinished projects. Kids would steal from each other if they ruined a piece, and of course then they wouldn't fit anyway because everyone has to be custom made. I would find the parts hidden inside the crank mechanism of the shaper, under benches, just any place they could stash something, you know, they would do. Human nature, but discouraging as a teacher. So we're getting close to being done here. No, we're not. Be right back. Here's the setup. The way I'm holding it, I've already drilled a pilot hole. Notice that I'm straddling the vise so I don't drill into it. And I already put a little bit of retaining compound on there. This came from Horrible Freight. We'll see if it actually works. And this is a 17/64 drill. Now you might say he misdrilled that hole. It's not in the center. I think it looks better off to one end than it does in the center. I think we call that the golden mean, or something we learned in design class. All right, let's talk about the handle now. A lot of different ways of doing this. Now at school, I did handles, all kinds of them. This is 3/16, this is 5/16, but I started with a piece of rod. This is 1/4 inch. I could use that for the handle. 3 inches long. Thread both ends and then put a nut on it. If it's a machine shop class, we would turn them on the lathe, nice and smooth and round. In other classes, they would grind them off, but if they didn't hold it on the wheel, the left-hand wheel, like this, so it was self-tighten, of course they wouldn't listen, so they're on the right-hand wheel, and bing, bam, that nut would spin off there and bounce off the wall, go clear to the other side of the shop. So that didn't work real well, but here is an alternative to that. And the alternative is to take 1/4 inch, rather long hex bolts, Make sure you don't get hardened ones. But the whole idea here is that we could put that through like this. Well, first of all, I would turn this down round, try not to get hardened bolts, and that would slide in there like that. And I'd run a nut all the way up against as tight as you can get it, cut it off to length, and round it off either on the grinder or on the lathe. And then you can remove these if you need to by wrapping emery cloth around them and twisting them off, and maybe Loctite them on at the end. And don't get too long a one, don't get too short. So this is probably too short by the time you cut it off. So here's one. Well, that's still pretty darn long, but I'm just giving you the suggestion on how to make handles by different methods. Well, lately I've been putting balls on the end of the handles, and I like the looks of that, but you know, these are way too bodacious. They look like bocce balls put on the end. So use something that's proportional. And what I've been on lately, the kick I've been on, and these just came in that latest video where I did a toolbox unpacking, that ugly green toolbox. There were a bunch of balls in there, this size. That's about 1/2 inch, doesn't matter. No one's going to do this. So these are harder than a rock, of course. They're ball bearings. So I've already annealed some, so they're soft, so I can drill them. I can put them in the lathe, face off just a little bit, so that you can then drill and ream. Now, I know I'm going to drill all the way through one and ruin it, so that's why there's 3. I'm used to, first of all, I'm very used to the kids screwing things up, so you always need an extra, but I've been known to do it myself. So let's go ahead and put this in the little Atlas lathe, and I'll show you how I'm going to do that. Okay, the ball is in the 3-jaw chuck on the Atlas lathe, and while you were at the bathroom or the refrigerator, I already faced it off. Now, I notice you guys go to the bathroom quite a bit while I'm trying to talk. It's just like teaching school. So anyway, now I'll come up with the center drill and I'll spot it good and proper. And, you know, I won't show all of this routine stuff. And then this drill is, can I get it in the frame or not? 1 size under quarter, and then I will ream it and hope I don't drill all the way through. Now, there's a marked tendency for the ball to get pushed back into the jaws when you drill it because there's not much jaw contact on a sphere, is there? Well, I'll be back in a few minutes. You know, I never did talk about annealing. That just means to soften hardened steel, and I think you all know that, and this was shown in great detail in other videos, including the annealing process itself. I remember doing that. I do not remember which video. Leave comments, please. Well, a miracle just happened. I didn't drill all the way through, and I only made 2 of them. Now, there's a little bit of retaining compound on the end of the rod, and it's a reamed hole, but it seems kind of tight. So let's see what happens here. Got to get it on straight. Well, I don't know why I didn't think about this before, but I stuck it in the hole so it won't roll around on me. Put some more goop on the end. Now let's see if I can get it in there. Okay. Now make sure you assemble it before you put the other nut on, or ball I should say. And since that's a struggle, I'm not going to show it, but same old deal. I'll be back momentarily. You know, I talked earlier in the video about the nominal size of some stock. Well, the reason I'm having trouble getting that ball on there is that this 1/4 inch stock is actually 4 or 5 thousandths oversized, so I just put this on the lathe and filed it down a little bit, and I'm going to pound it on there. It'll be a press fit without Loctite. No need. Now watch, it's going to go right on. Actually, you won't be able to tell, but you can tell by the sound, I think. Now I'm going to leave, I polished this up as you can see, but I'm going to leave the black on there. I kind of like the contrast, don't you? And it slides freely. That's why you got to drill one size over. Boy, that was a monumental job, wasn't it, for the screw? I just figured that would be a 5-minute part of the video, and it's already relentlessly long. Some of you like that though, I'm glad of that. Next, we need to fasten the guide bars into the two end pieces. Lots of ways of doing that. This is the sample here, and I just drilled 5 30-second holes all the way through, and this is 5 30-second rod. I made little pins. You could use roll pins. These are way too big. I did not have the right size, so that's why I'm using this, and then they can be Loctited in. I suppose you could even Loctite these in. I do not recommend that. You can also have threads on the end of the guide bars and nuts and a little shoulder and all kinds of other fancy and complicated ways of doing it. Now on this big vise, that's a blind hole. It doesn't even go all the way through, so those must be press fits. I really do not know. I don't see any set screws. You could use set screws with little flats too. I don't know if that's a good idea. If your holes are oversized, it's going to force the rods out of alignment just a little bit. Now on the sample, the prototype, notice that I even put little witness marks. There's 4 there, 3 there, and similarly on the other end. So I assemble it because when you drill these cross holes in there, they're not going to truly be in the middle, although I have carefully and methodically laid out 4 holes, 1, 2, 3, 4, and I'll drill 5 30-seconds all the way through, and each time I do that, I will put a pin in there so it cannot move. I'd like them to be flush here as the best I can, and make sure you don't put anything on backwards, and of course that's why I put one on backwards, to show you that. So let's get that corrected before I do something crazy, because I'm starting to get tired. Alright, I've made up 4 of these 5 30-seconds pins. They're really fussy to handle this small stuff. You're probably better off with roll pins. The only problem with roll pins is if you're going to take it apart over and over to do your final fitting, you have to drive them out. So I guess that's why I'm going that way. And I don't want to go to Ace Hardware. I'm not in the mood. Believe it or not, there's something I don't have in stock. So I've already piloted these just a little ways in with a small bit. I'm not going to show it, but I'm going over to the drill press one at a time. I already said this, I know. And drill all the way through, deburr it, put the pins in, put the witness marks on, and I'll be back in 7 minutes. Some of you may have noticed while I was drilling that I had this little vise on there to try to control any movement. This piece is just a little bit too long, so I'll take that off now. And I already put the witness marks on there. Might not show up too well on the camera. You don't have to do that. That is optional. And then I know this, there's probably a lot of shop teachers watching this, and if you're a beginning teacher, you're going to say, hey, that's a great project. If you're an experienced teacher, you're going to say, you know what, my kids couldn't make this in a million years. To start with, you'd need to buy 200 or 300 drill bits this size, because I would consider that a rather deep hole to drill. I guarantee that they're going to break these off by the dozens. And then you've got a $2 pin in each one with a jagged end. So yeah, this would not be a good project. It's as simple as it looks. It is not that simple. So we got some deburring to do, and this jaw seems to slide fairly easily without binding, but will it when I put the screw in there? So that's what I'll do next, and let's see what happens. Well, just a little bit of oil. A little bit? Holy mackerel. I just put a pint on. Alright, I've just got this snugged up, and it does move. And will it move backwards? No, there's a bit of a bind. So, here's what I'm going to do now. I'm going to take it apart again because I've got some deburring to do, and you see it's easy to take the pins out. And I'm going to trim this bar off just about a 32nd of an inch or less, and I will take this jaw and I'm going to open it up, open those holes up just about 2 or 3 thousandths with this adjustable reamer. I don't want this much slop, but even if there is, it isn't going to hurt anything. But that's what happened on this one, that, you know, there is just a little bit of a bind, and I would like it to move freer than that. And we do not want to count on wearing in. You know, a lot of people say, well, just let it wear in. All right. Now I tell you what I'm doing next, really. I've been working on this for about 6 hours, and I have the need for a nap. So I'm quitting for the day, and I'll get back with renewed energy and 3 cups of coffee in the morning. So I'll see you in 12 hours, or actually 1 minute, 1 second. Okay, it's the next day, and I feel so much better after that short snatch of death. But as you will recall, what I was doing here was to open up these 2 holes a little bit. They were reamed 1/2 inch, and it's just a little bit tight. So, excuse me, I'm going to use this 1/2 inch expandable reamer, and I've already set it. Now you can set them by tightening or loosening this little screw here on the top. There's a flat, as you can see. I just did that with a wrench, and I mic'd it. So it's kind of hit and miss. You make an adjustment, and then you got to mic it. And at the present time, I'm at about 503 thousandths. So I'm going to ream these 2 holes that side and see how it fits. And if it's still too tight, I'll readjust it and do it again. And here's how I'm doing it. I'm just holding the reamer and the bench vise, and I'll turn the work on it. We'll see how that works. Always clockwise. Okay, I've gone down to about the middle, and now I'm coming back up. Taking it off, that is. And I'll see how it fits. I'm not going to measure it with a micrometer or a bore gauge or anything like that. I'm just going to put it back on the rod. So this one is what I just reamed without. This one has a little green mark on it. You probably can't see it, but if we examine the reamer, you'll see that there are chips on it. So this is the hole I just reamed, and it fits on much better, looser, I should say. Little bit of wiggle, but we got to have that wiggle. I'll go ahead and ream this one, and that should do it. Okay, I think that's a lot better. Let me go ahead and put the fixed jaw on and see if it truly works, but you can see there's a little bit of a wiggle there. I think it will be a lot better. I also wanted to tell you that you can buy regular reamers. You can buy these by the set or any different size, and they just have a little bit of a range. In other words, you're not going to change this one to a 9/16. Just a little bit above or below 1/2 inch. And you can also buy regular hand reamers and chucking reamers in undersize or oversized decimal sizes. They are very readily available, but unless you use them real often, it doesn't pay to own them, because you'd be $30 or $40 for a reamer. So let me put that jaw on. Okay, opening these 2 holes up made all the difference in the world. So now it's just smooth operation in and out. I'm ready to machine to the proper width, so I'll show you how I'm going to lay that out. Not much left other than to Loctite this screw into place so it can't back out. I'll just use blue Loctite so it can be adjusted if necessary. This is all done. There'll be a lot of cleanup work to do. Polishing and stuff like that. It could be surface ground if you have a surface grinder. I do not, nor do I like to do that type of finishing work, as you well know. So it's looking good. We're coming to the final stretch. Okay, take it apart one more time. The screw is out, and I want to collapse all the jaws. I've removed these 2 pins, and I will. It's a little tighter, but it's all right. As you can see, the ends are not even, so I'm going to mill them off. And let me do the layout. So that's why I took these pins out, because I'm going to take this little depth gauge, which is also a square. This is about 1/4 inch wide, so I'm going to set it up against the top here and against the guide bar right here and scribe it. If I can find Randy's scriber here. So I will scribe it right there and do the same thing on this side. And that's going to give me jaws that are, well, I don't know how wide yet, but it's going to be about 3 3/8. We'll see. It doesn't really matter unless you are going by a dimension that is important, and that is not. So I'll scribe these, and then let's step over to the milling machine and see how we're going to hold this. Well, the layout is done, and you can see there's not very much to take off of either side. That's 1/4 inch past the guide bar. Alright, I'm going to hold this in the vise vertically like this and just mill it down to that line. There's a lot of ways of doing that. It also could be held in the Bridgeport in this. I'd have to take the rods out and pretend this is a milling cutter and mill it with the sides. Actually, that would probably give me a better cut. Let's go on over to the mill. At the Bridgeport mill, again, a lot of different ways to do this. I'm going to use this 2-inch end mill. I was going to use this 1.5 inch, but we have 1.5 inch wide here, so the 2-inch will be perfect. I put it in back gears, about 250 RPM. So I need to square this up, and I'll do that by putting the little Craftsman square right up against the work. You almost need 3 hands for this. And tightening the vise, which you can't see. Now I'll double check that in a minute here, but I need to hold these together with this Proto C-clamp. For best results, use a Proto, Armstrong, or I don't care what you use. Alright, but anyway, this is a heavy-duty clamp. I'll clamp her down tighter than a bull's hind end in blowfly season. Okay, let's take a trial cut here and see what happens. A little deeper. And this will be the second roughing pass. Notice there's some oil on there. Get your glasses on. Well, the finish is not that great. The cutter must be a little dull, but it's good enough for who it's for. So this will be the finishing pass now, taking off about 8 or 10 thousandths right now. Remember that in back gears on a Bridgeport, you have to run the motor in reverse. Okay, I'm done with this side. I did remove the burr here so that I can, and I'm looking at the layout line, which kind of disappeared on me, but using the little square without a burr on there, I'm able to determine, and I'm bringing that blade up against the bar, and it's right on. So what I'll do now is I got to clean up everything really good, real well. Deburr this and then repeat the whole thing on the other side, and I won't show any of that. I'll meet you at the bench momentarily. Let me explain something here. The reason I'm feeding in this direction is because there's so much work extending out of the vise. I thought that if I fed in this direction, there is the possibility of it moving, so that's why I'm doing that. But if I had fed in the X-axis, I would have been able to use my new, you can't see from here, my new power feed on the X-axis. However, one other thing I could have done, of course, is to turn the vise at 90 degrees and use the power feed. So there's just so many options, but it worked just fine the way it is. And now I truly am going to take it out. I already took most of the burrs off, and I checked the second side also with that little square. All right, the final width of the jaws is about 3 5/8. So what I'll do next is I got to take it all apart again off camera and just do a little polishing, that is sanding, filing, breaking the corners and all of that. And I won't show you all that tedium. I'll be back in a few minutes. Okay, I did all the cleanup work on the abrasive sander, the 6x48 Delta. You could draw file it, you could surface grind it, do darn near anything that you want to. You could do jeweling, that is engine turning, or blue it, or black it, or whatever. Let me go ahead now and reassemble it for the final time, although I almost took off most of my index witness marks. Just finishing up, I'm about ready to cross the finish line, so I'm using Loctite on the 4 pins. Another way to do that would be just to put a little pinch mark on there like a knurl in the vise, and that will hold it in place. Loctite on this screw, but not cranking it down. It needs to be brought down into the groove or the slot and then backed off a little bit with the Loctite, and then it'll set overnight to set up, and it all works nice. Let me make a couple comments. We are done. I am done. I hope you enjoyed the video. Give me a thumbs up if you did. I know it was a marathon, but is this suitable for a school project? What do you think? I think it's really way too difficult, especially for a beginning class, because with all the reaming and everything that you need to do, it's necessary to use a milling machine. You can do it on a drill press if you're skilled enough, but if anybody is to make one of these, let me know, send me some pictures, and look back in the description of the video from time to time for announcements. Possibly if someone submits a drawing and puts it on my heap, I would announce that if anyone's interested in making this. Now, should you decide to make one of these, you do not need to make a prototype. I made that for you. So there was a lot of work even in this piece. In other words, in developing a project. And that's what takes so long with shop teachers, if they are dedicated to their job, to come up with projects, make prototypes, try to see if they're foolproof for the students or appropriate for that age level. And remember, kids are coming into my shop, or did, and they could not even read a ruler. They did know what a screwdriver was and some common tools, but often they had never touched a tool anywhere if they grew up in an apartment building or something like that, before they came in. So something that looks simple isn't always that simple for a student. Well, thank you for watching and sticking with me. I hope you watched both parts. And there again is the final sample. There'll be some pictures at the end. Again, please give me a thumbs up. That helps me more with the channel than anything else. I don't beg you for money or anything like that, but I do kind of beg you to give me a thumbs up or a like. That's what gets these videos spread around YouTube, hopefully. All right, that concludes this video, this project. I'll see you next time. Remember, I have 1,500 videos for you to check out at your leisure. One more thing. I know I'll one more you to death, won't I? If this video is a success, that is, do a lot of people watch it, I might come back. It won't be part 3, but it'll be just another video on this, a short one where I make some other improvements, namely to put a slot like this in here. I've done that before, and a V-way, maybe even a double V-way, which you see here, and the possibility of dressing it up a little bit by putting a bevel here and here, or here and here. So there's a lot of different things that can be done. I didn't want to do that in this video because it's already too long, but that's potential fodder for a future video, but only by popular demand. And boy, do I have a mess to clean up in both shops on many different machines. But that's the fun of it. I really enjoyed this. I hope you enjoy working in your shop. You know, I'm a little late to the party here, but I guess I'll tell you this anyway. And remember, I talked about this adjustable reamer. Well, all of a sudden I dug out this reamer, which is brand new. It was still in the tube here, and it is an oversized reamer, and I hope I can get this in here, but this, I could have used this, although it is a power reamer. I would have preferred a hand reamer, but looking at the etching on here, you can see that it is 505 thousandths. Does that show up or not? Probably not. So that's an oversized reamer. It also has a metric size on here. And I could have used this, because you see it will not fit into that, but that would have been perfect to use. Too late now.